first term of a geometric progression is 6 times the fourth term. Find the two possible values of the common ratio.
Okay, let's stop there. Let's do A first. Sum of the second and third term of an AP. This is the second term of an AP, AR. First term is A. Hello? This third term, AR square. You say when you add the two together, it's equal to 6 times the what? Fourth. This is the fourth term. Is that correct?
Yes, sir.
Hello? Is that correct in your question? Is it not fourth term?
It's fourth term.
Yeah. So fourth term is AR raised to power 3 or AR cube. Now, the first thing we need to do, they ask us to find two possible values of R. R is equal to X or Y. So what is the value of X or Y? From the equation, there is likelihood of ending up with a quadratic, even without solving first, because it's only quadratic that you will solve that you have two possible answers. Yes or no?
Yes, sir.
Now you are going to factorize the left hand side. A is common to the two terms, R is common. Bring A and R out. It will remain 1 plus R in the bracket. Then divide both sides by AR, because AR is the common term to the two. Why are we doing this? The main goal is to make R the subject of our equation. R is the subject of what? Our equation. So you have 1 plus R to be equal to 6 into AR raised to power 3 divided by AR in the denominator. Now you have 1 plus R. How do we make 1 plus R? Rearrange it in such a way that it will not be an equation with fraction again. How well can we reduce all this fraction denominator to eliminate this denominator, and of course to get rid of this one at the back of R? You are not listening. A is common to both numerator and denominator on the right side, so you divide both sides by, you divide the numerator and denominator by A. So you have 6 R raised to power 3 divided by R is equal to 1 plus R. Following the laws of indices, since these bases are the same, this one has coefficient 6, this one has coefficient 1, the variable are the same. We are going to subtract the power of the variable down from the variable at the numerator. So you have 1 plus R to be equal to 6 R raised to power this 3 minus 1, that is the power of the denominator. When you do that, you have 1 plus R is equal to 6 R raised to power 2. Then you are going to equate this to 0. That means you move all the variables and the constant to one side and make it equal to 0. So when you rearrange, you will have this 6R square is already there, plus R. When you move it, it becomes minus R. Then this one, when you move it, it becomes minus 1, all equal to 0. So this now is quadratic. It becomes a quadratic, and it's aligning with the equation that you find the two possible values of R. Now analyzing this quadratic using factorization to solve this quadratic, you discover that if you multiply this coefficient of R square by this minus 1, you are going to have minus 6. Then the coefficient of R is minus 1. So we look for two numbers that when you multiply them together, you get minus 6. And when you sum them together, you get minus 1. Those two numbers are minus 3 and plus 2. Those are the two possible numbers, though there are other factors. But this is the only one that can go with what we need, minus 6 and minus 1. So you use it to replace this minus R. So you have 6R squared minus 3R plus 2R. Minus 3R plus 2R will give us minus R. So nothing has changed. We only express this minus r in another form. If you sum this together, it will give you minus r. Do you agree with that? Now take these two. What is common to them? 3r is common. If you take away 3r from 6r squared, it will remain 2r. Take away 3r from minus 3r, it will remain minus 1. Come to this other one too. 2r minus 1. What is common there? 1 is common to both of them. So it will remain 2r minus 1. All equal to 0. So factorizing and grouping them together. 3r plus 1 into 2r minus 1 is equal to 0. Then when you open up the factorized terms, it implies that 3r plus 1 is equal to 0 or 2r minus 1 equal to 0. Now you try to make r the subject of each of them. 2r is equal to minus 1 or 2r is equal to 1. Then divide both sides by 3 on this first one. You have r to be equal to minus 1 over 3. Divide both sides by 2 here. You have r to be equal to 1 over 2. So the two possible values of r are minus 1 over 3 or 1 over 2.